Let's talk about LeetCode 2948. Make lexicographically smallest array by swapping elements. It gives us an integer array nums and also a limit. So that means if in these nums, any numbers have absolute differences small or equal to limit, then we can swap any times. We want to return the lexically smallest array by performing the swapping. It is defined, for example, array is lexically smaller than another one if the first position where the two array differs and array A has element that is less than the corresponding element in B. For example, 2, 10, 3, and 10 to 3, the first diff is 2 and 10, right? 2 is smaller than 10, so let's say array has lexically smaller than B. It say that if two numbers the within limit, then we can swap any times. So let's look at this. Let's look at the example two, right? Let's say um this one to one, right? Actually, this one we can consider the because the greatest one is two, right? And the smallest is one. They are has within the limit three, so we can swap these three numbers. And also, you'll see that the greatest is two, right? Let's look at the next one. That is six. Let's say this count 6, 7. They are in one group because the smallest six in this group is greater than 2 plus 3, right? And then the rest is 18. So that means in order to get a lexical smaller number, what we can do is that we can reorder those kind of numbers in one group. So for example, we'll put this one and this one and this two here, right? And for this one, we can put, for example, this is 6 and 7, right? And this one itself is one group. We cannot change anything. So we can thinking about do some grouping and reordering, right? But the thing that so if we do reordering, of course we need a sort, right? But for this question, if we sort, those kind of index will be changed. So we need to sort by passing the indexes. What we do is that we create a new array with index and sort. So after sort, for example, it is 1, 1, 2, 6, 7, right? And 18. And we have its indexes. So this is 0, 0, 1, 2, 3, 4, 5, right? 5. And this is 4, right? And 6, this is 2, 1, 3. So the thing that we should place what? Place it in a new order that which can sort this kind of index as well, right? As 4, 0, 4, 5, 0, 4, 5, and this one as 1, 2, and 3, right? So we put this kind of number into for the result in index 0 to this number to index 4, and put this number to index 5, put this number to index 1, put this one to index 3, recompose the result. So after this analysis, we can record for this, right? Um, we because we want to pass in the indexes. So we need to create a new array. Let's have an int array equals new int and multiply by 2, right? So what it is the for int I equals 0, that's smaller than n I plus plus. We're going to have array I 0 equals nums I. And also array I 1 will have the index into it, right? Then we can sort this kind of array. Um, we then we after we sort this kind of arrays, right? We have three parts. For each part, we also need to sort its indexes, right? And put those kind of sorted values to its sorted index. So we can, of course, use a list every time we finish iterate this group sort list, right? We can also use a tree set to put those kind of IDs. We want to up after end of this group, right? We want to iterate from start of this group, right? So we can use a last to put as the start of our group and to fill in the result array. So we can have tree set integer to put IDs equals new tree set, and we're going to have int result equals new int n, and we can use a last variable equals 0. Okay. So what we do is that for int I equals 0, I smaller than n, I plus plus, we're going to have IDs tree set at I, right? So at the end of the group, what we need to do is that if I equals n minus 1 or array I 0 plus limit smaller than array I plus 1, 0, right? So that is at the end of a group. Of course, we need to have these IDs to be clear, right? Because for every group, um, we needed to have a new sorted arrays, right? And before we clear, what we do is that we just for into um, into ID in IDs. What we do is that we are going to have result ID equals array last 0, right? Of course, our last should increase by 1. In the end, just return result. For tree set smaller than array. Let's take a look. This is not add I, right? This should be add array I1. That is original index, but this is this index. We should not use this. And it's also write Python code for this, right? We can also import the sorted set for sorted containers. Import sorted set, right? So what we do is that we're going to have create a new array and equals the length of nums. and we're going to have array equals nums I and I for I in range and array sort. So we're going to have IDs equals sorted set, and result equals this one multiplied by n, right? And we have a last equals there. Then for I in range and going to have I this can sort set at array I1, right? Because this will be the original IDs. Then what we do is that if I equals n minus 1 or array I0 plus limit is smaller than array I1. That means we are at the I plus 1, right? Plus 1, 0. We are at the end of one group. Then we're going to have we're going to put for this group rearrange, right, for every ID in let's say for in ID IDs. Okay, going to have result index equals array last there. Of course, we should have last plus equal to 1, right? And we should clear in the end. Return results. Line 1 for from body containers. Then like this, we have because we have a sort, right? This is n log n time complexity, and this is also an uh, log operation for every insert, right? So this is also n log n time complexity. So time complexity total is n log n, and the space is O n because we just sort this set, and also create a new array.